Hello everyone. In this video we're going to learn about the very famous error which is called StackOverFlow error, and we're going to see that when and why we're seeing this error. So here I wrote a very simple program to calculate the Fibonacci of a positive integer. So the program simply asks for a positive integer and then calls the factorial function, as you see here, which is a recursive function, which because it's called itself, so the factorial itself is called, but with the smaller subproblems. And we're going to see that what can go wrong to see that famous error, StackOverFlow error. I'm going to run the program with this version, which is a correct version, and it's going to return the number properly. And again, we are not worried about not being able to fit the factorial in the enough memory. I use long, but it still is not enough. But again, we're assuming that we're not dealing with it. We're just going to focus more on the recursive problems. So I'm going to run the file, and here it asks me for a positive integer number, for example number 5, and it reads 5 factorial is equal to 120. But let's see that what can go wrong. First of all, if we don't have the base case, for example, if I remove, or let's just comment the code for now. So I'm going to comment this code here that returns or just the base case. So here I'm just simply returning the number n times the factorial of n minus 1. So here I don't have the base case. So there's no way that this method will gonna stop. So I'm gonna run the program one more time, and this time we're gonna see that after, for example, entering number 5, it gives me this error. As you see here, the problem crashed because I didn't have the base case. So there is no way for this problem, for this program to stop. So here is the StackOverFlow error because there was no the base case, and it goes to negative infinity, in general, and that's because we have like a limited memory, and we cannot just store all the the calls to the factorial is gonna give us the StackOverFlow error. And at the end of this video, I'm gonna just explain also how in more details why this error happens. So another problem is that if we have the base case. So here is example, we have the base case, but we are not actually going to we're not reaching the base case. For example, let's say here instead of n minus 1, by mistake we have written n minus 2. So or maybe n plus 1, which means that n will increase by 1 all the time, and we're never gonna reach to n equal to 1. So this code that you see here will work for some cases, but not for all cases. Here's an example in which it's going to work. For example, if I type 5, it's going to work properly. Not properly but at least it's not going to fail, because I said n times factorial of n minus 2. In some other cases, like for example, if I let's keep the n minus 2, but test it with, for example, number 6 this time, and it again crashed. The reason, because when I'm deducting number 6 by 2, it's going to be 4, and 4 minus 2 is going to be 2, and 2 minus 2 is going to be 0. So it's never going to reach number 1. Although the code that we have written is not accurate, but I just wanted to show the cases that something can go wrong if although we might have the base case, but because the steps that we're taking to go to the base case is not accurate, then we're going to end up with the StackOverFlow error. So we can see that even with the very simple functions such as factorial, we can easily write it in the wrong way, so it's not going to stop. So the correct way is just as you see here. We have the base case if n equal to 1. Also in the else statement, if n is not equal to 1, it's going to multiply n by the same function, the factorial function, but this time with the smaller sub problem, which is n minus 1. Again, if by mistake we type here n plus 1, which is again is not an accurate formula for the factorial, but if there's a bug, then we're going to see that the stack overflow error. So shortly I'm just going to again show that why we actually seeing this stack overflow, and the reason is that we're actually in a stack to keep the calls to to the recursive functions that we have. Looking at the code again, this time we're going to see that why we're seeing this stack overflow error in more details. I'm going to start with the code that was not working. One way of again just messing up with this code, and here's the one, and we're assuming that we're going to calculate the factorial of number 5, which is going to be based on the code we have here is equal to 5 times factorial of n minus 1, which is factorial of 4. So to calculate the factorial of 5, that's what's going to happen. We need to first calculate the factorial of 4. So which is exactly the concept of the stack, because in a stack we're saying the last in first out. So the factorial of 4 is the last thing that have been needs to be calculated, the last thing that's going to be inserted, but it's going to be the first thing to be calculated, which is, so here I'm going to have 4 times factorial of 4. So to calculate factorial of 4, we need also to calculate the factorial of 3 and so on. So it's going to be 4 times factorial of 3 and 3 times factorial of 2, and then 2 times factorial of 1. In a proper code, in an accurate code, the stack should stop here by returning 1 as the value of factorial of 1 and popping all the all the values, and finally popping the value of the factorial of 5. However, in this code that we see here, we don't have the base case, so this will go forever and ever until we just running out of the memory. Means that after this we're going to have another thing on top of this. We're going to be 1 times factorial of 0, and then 0 times factorial of -1, and so on. So it's going to continue as long as there is no more memory available to keep items on top of the stack. And so you can watch my other videos about the stacks, implementation of the stacks, using linked lists or using arrays, or also my previous videos about the concept of the recursive functions.